Hello everyone and welcome to our session. In this session we will take some tricks. I'm gonna call it bag of tricks. There's four tricks I'm introducing here. The first trick, sometime when he gives me a circuit, he would have one way for a current to move from this loop to the second loop. If I see something like that, I would right away consider that this wire has no current in it. Why? Because it's not allowed to. Let's think of it as two settings. If this is setting number one and setting number two, and there's only one highway that has a one way, because each wire here, it's not like streets, each wire has only one way. The current can move in one direction. So if this city would send the current in that direction, it's stuck here, it can't go back. And all the circuits about cycling, it's about going in a circle. So since we can't move back, then this wire would have a zero current. So I'm gonna have two separate circuits, one here and one there, but thank God that we have a dependent source, because this dependent source would depend on one of the currents in this circuit, so they're still related even though that they have no connection between them. Why? Because there's a dependent. Maybe I'm gonna call here a current, I'm gonna call it current IX, and I'm gonna call this dependent source 2 times Ix. Here we related this loop to this loop. How? If we find the current here, we double it and we find the current in this dependent source. So usually the dependent source that connects this source to some point in the circuit. Okay, this is trick number one. Let's go to trick number two. Trick number two, usually most of the professors would test your observation about the sign. Now, if he gave you a positive and a negative, if I look at this circuit, it's simple. It only have two elements, a voltage and a resistor. We talked about how to put a node. We said the node would start from one end and keep going to reach another end, and then keep going if there's more wires until it reach a third end, a fourth end, until it's until there's no way to like draw a line without moving your pen or your hand off the paper. So here I started coloring red, going here and then there. I end up at this resistor, and that's it. You can't go anywhere else without taking off your hand from the paper. So this is node A and this is node B, same way. Now, if I see it here, I can see that the positive is in this for the source is closer to node A. The negative sign is closer to node B. Here, the voltage on this resistor, he gave me the voltage. He wrote the voltage down, and he put the polarity, the negative up and the positive down. Now think about it. Since the negative is on top, like toward A, and the positive down, it's the opposite as this. This is the positive toward A and negative toward B. Here the opposite. That means this voltage has to be negative in sign. Why? Because it's opposite the polarity. Now how would I know how much is the voltage here? Just think about it. Here the voltage is 2, and those are parallel. We will talk about parallel later on. Here I'm just introducing the trick of the negative sign. Since they're parallel, they have the same nodes. Then this is this voltage should equal this voltage, so it should be a negative 2. Why? Because it's the opposite sign. Now if he gave me a current in that direction, how would I know if this current has a negative sign or a positive sign? Now a source, we said a source would supply a current. That means the current would move from the negative to a positive. Here, this is a source, this is a negative positive, it has to go that way. While the resistor the current has to go this way. Why? Always in most cases, I would say, the source is supplying power. So that means the current would go from a negative to a positive. Okay? In most cases, in all cases, the resistor should absorb power. So it moves from a high to a low potential. Okay? So this current, since it's moving in the source, and this is the only source in the circuit, so I'm gonna call this to be a negative sign. Okay, we will discuss how to find the current later on, but I'm just focusing on how to know if it's a positive or negative, and this trick is important. Usually they some missing points would be taken off the students. Great. Now number three, if, for example, I have a switch, okay, and we will talk about a switch later on, and I found out that this circuit is broken. Why? Because there's a switch, and the switch is open. That means there's no current is flowing here. There's no loop, right? There's no closed path for the current to go. So this current Ix is 0. Now if this current Ix is 0, if I look to the other side, I said this, I would just erase it. I would erase this wire. There's a dependent source that depends on the current here. This dependent source has the value of double Ix, so 2 times Ix. Ix, we said it's 0, so this should be a 0. Now what does that mean? The current is 0 in the dependent source. I want you to pay attention. If the current is 0 in the dependent source, that means, or the value of the dependent source, the current dependent source is 0, that means it's an open circuit. That means you just remove it from the circuit. While if it was a voltage source and the value of the voltage source is 0, that means it's a wire, it's a short circuit. Why? What does a 0 volt mean? Is that it's a wire. You know, there's no difference in voltage between this point and this point. So it's a short circuit. Pay attention to this. If for some reason the dependent source has a value of 0, look, if it has an arrow inside it, that means it's an open circuit. If it has a positive and negative, that means it's a voltage. This means it's a short circuit. Okay? Let's move down to our fourth trick. Our fourth trick, and it's the final trick, is whenever I have a wire in the middle, you know, or somewhere, this wire is called a short circuit. That means when the current comes here, the current would be given two choices, to go from here or divide, right? Usually I'm gonna give you one information here. The current would rather to go through the lesser resistor. Like, which one is smaller? The current would rather to go, like, a plenty of the current would go in the smaller resistor, and the small current would go in the higher. But if for some reason I had a wire, there's no resistance at all, that means all the current would go through the short, and none of the current would go through the resistor. So it's like you're saying the resistor does not exist in this circuit. Another way of seeing this is to name the node. This is node A, right? I ended at this end, and this end. There's no more. Now B, if I move, just think of a water that is running here and finds two ways. Some of it goes here, some of it goes here, until it reaches this end, stops. But this one keep going, it divides, go here, stops here, and then the other part would go here, and then it will split, end up here and here. So all of this, the one in orange, it's called node B. Now, since this resistor is having a same node, any resistor that has a same node, BB, you can erase that resistor from the circuit. Okay? So, sorry for the interruption. Now here, if you look at this one, this is node and A. I went through all the circuit without taking my pen or my pencil off the circuit. That means that this resistor has AA, so you can delete it. This resistor has AA, then you can delete it. So the current, all the current would move here, would rather to go from the short circuit and continue through a short circuit and comes back instead of going through a resistance. The resistance is like a struggle for the current, you know. It would rather to go through the short circuit, the easier path, than going through any resistance. Okay, so those are the 4 tricks. It's so important. I'm gonna review them very quick. Trick number 1 was, if there's a wire, single wire, and there's no coming back, just delete it. Trick number 2, if you have an opposite polarities, then this voltage is a negative if this was a positive, or if you have a current that is going through a single source, there is no other sources. If there is only one source, this source should be supplying. So the current is going in the positive and then leaving from the negative. This means this current is wrong. That means this current has a wrong direction. That means it's a negative. Trick number 3, if I have any dependent source with a 0 value, look at the inside the dependent source. If it's an arrow, that means it's a current. You make it as an open. If it's a voltage, you make it as a short. And the last trick was, if any resistor has the same node, then you can delete that resistor. Now next video we will talk about the switches and then take some examples on those tricks combined with the switches concept. So see you next time.